Okay, so in this video, we're going to calculate the effective rate for two savings accounts, two bank loans, two bank accounts from different banks that are earning slightly different interest rates and compounding at slightly different frequencies. And what we want to be able to do is we want to compare, given the information that we have, the rate and the compounding frequency, how much interest am I going to earn effectively at the end of a year, at the end of a cycle, in order to determine which rate is actually going to get me the better interest, the better amount of money earned. Typically, of course, the higher the interest rate is better, but on the other hand, compounding more often is also better. And here we have them at odds. We have a 5% interest rate at Bank A, but they're only compounding quarterly. Whereas Bank B is earning a slightly lower interest rate, but it's compounding daily, which is much more frequently. And so we want to calculate is the effective rate. Essentially, if I put a certain fixed amount of money in both accounts, which one is going to earn the higher interest rate at the end of a year, not a single period, but at the end of a year. So we're going to calculate the effective rate. We're going to use the effective rate formula in Excel, but there is a formula for the effective rate. And essentially it is the compounding formula for just like principal in the account. But essentially you're going to put $1 into the account, and then you're going to calculate the rate or the interest earned in 1 year. And then to get the rate back, you're going to subtract off the original $1. So we can do one of the calculations with the formulas, but really we want to be able to use Excel for this. So I've set up a little table that we can put our values in. The 5% rate, and in our first bank, we want to put in quarterly, so it's compounding 4 times per year. Our second bank is giving us 4.9% interest, a little bit lower, but it's compounding 365 times per year. Now, the effective rate formula, again, if you've never used it before, use the insert function and search for it. Effective rate. And what's going to come up in this case, we want the effect. That's short for effective rate. And what it's going to tell us is to put the nominal interest rate. That's the one they tell you. That's the annual, the APR. We're going to put that in here. And then N per year is the number of compounding periods per year, because essentially we're only doing this. How much money would I earn at the end of a year? And then I hit OK. And again, I can convert this to a percent to make the display a little nicer. So essentially 5.1%. Now, if I do this with the 4.9, because I've set up my table, I can copy the formula down. I don't need to reproduce the formula. Now my annual rate is the 4.9, and the 365 is the number of times per year. And this is giving me 5.02% instead of 5.09%. So if I was compounding 1 time per year, then the reported nominal rate, the APR, would be identical to the effective rate. And so 4.9% would be better if I'm compounding it daily than 5% compounded 1 time per year. But here, the 5%, that even that extra 0.1% is going to give me a better effective rate, even though I'm compounding so many more times. The very fact that if I'm starting at a higher rate, the number of times I'm compounding does do more, but it doesn't do enough more to overcome the initially higher rate. So Bank A does turn out to be the better account if it's a savings account, because I'm getting a higher rate. Now, if this is the loan, of course, you want the lower effective rate, because that means you're getting charged less interest. Now, and I said what we could do is we could actually use the formula. And so I am going to use the formula here. I'm just going to set my table up again for this first example. And if I just use the formula as written here, 1 plus, it's the annual interest rate divided by the number of compounding periods, raised to the number of compounding periods minus 1. And again, I get exactly the same value I got before. I'll just turn it into a percent so that we can compare it easily. And I get exactly the same answer using this formula. But if I use the built-in formula in Excel, I just have to tell it, what's my rate, what's the compounding period, and it does the rest of the math for me.